Far beyond the orbit of every planet, beyond the fading influence of the Sun, a lone spacecraft continues a journey that no engineer expected it to complete. There are no planets nearby. No familiar constellations fill its sky. Only an endless ocean of darkness interrupted by distant stars whose light has traveled for years to reach this isolated traveler. That spacecraft is Voyager 1. Launched in 1977, Voyager was designed to explore Jupiter and Saturn before its mission quietly came to an end. Instead, it accomplished something no human-made object had ever done. It became the first spacecraft to leave the protective bubble surrounding our solar system and enter interstellar space. Even today, decades after launch, Voyager continues sending tiny streams of information back to Earth. Those faint signals represent one of humanity's longest-running scientific conversations. Every transmission reveals something about a region no spacecraft had ever explored before. Contrary to popular belief, the space between the stars is not completely empty. Invisible magnetic fields stretch across enormous distances. Charged particles travel at incredible speeds. Thin clouds of plasma drift through the galaxy, shaped by ancient stellar explosions and the gravity of the Milky Way itself. Voyager is moving directly through this invisible environment. Its instruments record changes in particle density, cosmic rays, and magnetic fields that help scientists understand how our solar system interacts with the rest of the galaxy. Occasionally, the spacecraft detects something unexpected. A sudden increase in energetic particles. A change in plasma density. A shift in magnetic conditions unlike previous measurements. When unusual data appears, researchers do not immediately assume something extraordinary has happened. Instead, they compare observations, verify instrument performance, and carefully examine every possible explanation. That process is what makes science reliable. Yet even after decades of study, interstellar space continues to surprise astronomers. Some regions appear more turbulent than expected. Others seem remarkably calm. The boundaries between different plasma environments are far more complicated than early computer models predicted. Every discovery raises new questions. How do cosmic rays travel across the galaxy? What shapes the invisible magnetic structures surrounding our solar system? How does the Sun interact with the interstellar medium over thousands of years? Voyager is helping answer those questions one measurement at a time. Its age makes the mission even more remarkable. The spacecraft relies on technology designed in the early 1970s. Its memory is measured in kilobytes. Its processors are slower than those found in the simplest modern electronic devices. Yet careful engineering has allowed Voyager to survive radiation, extreme cold, and nearly 50 years of continuous operation. Its power source, fueled by slowly decaying radioactive material, produces less electricity each year. To extend the mission, NASA engineers have gradually turned off heaters and non-essential systems. Each decision preserves enough energy for the remaining scientific instruments to continue operating just a little longer. The distance creates another incredible challenge. A radio message sent from Earth requires nearly an entire day to reach Voyager. The reply takes just as long to return. Every conversation with the spacecraft unfolds over almost 2 days. Despite these enormous delays, Voyager continues faithfully carrying out its mission. Someday, its final instrument will fall silent. Its radio transmitter will no longer have enough power to reach Earth. When that moment arrives, humanity's oldest explorer will continue drifting through the Milky Way alone, carrying the famous Golden Record and the story of a civilization that dared to explore beyond its home. But until then, every faint signal reminds us that even the darkest regions of space still have stories waiting to be discovered. For nearly half a century, Voyager 1 has been traveling farther from Earth than any other human-made object. Every second, it moves deeper into a region that no spacecraft has explored before. There are no maps waiting ahead, no previous missions to compare with, and no guarantee that the next discovery will match our expectations. This is true exploration. One of Voyager's greatest achievements is helping scientists understand the interstellar medium, the enormous expanse between the stars. While often imagined as empty space, this region is actually filled with an incredibly thin mixture of charged particles, magnetic fields, and cosmic rays traveling across the galaxy. These invisible ingredients shape the environment surrounding our solar system. As Voyager crossed the heliopause, its instruments recorded dramatic changes in particle populations and plasma density. Those measurements confirmed that the spacecraft had entered interstellar space, but they also revealed that the boundary is far more complicated than researchers once believed. Rather than acting like a sharp border, it appears to be a constantly changing transition zone influenced by both the Sun and the surrounding galaxy. Another fascinating discovery involves cosmic rays. These energetic particles originate from distant supernova explosions and other powerful events across the Milky Way. Before Voyager left the heliosphere, many of these particles were partially blocked by the Sun's magnetic influence. Beyond that protective bubble, the number of incoming cosmic rays increased significantly. For scientists, this was an opportunity unlike any before. By studying these particles directly, researchers can better understand how energy moves throughout our galaxy and how stellar explosions continue to influence space long after they occur. The mission has also become a remarkable engineering success. Voyager's computers were designed in the early 1970s, yet they continue performing tasks billions of kilometers from Earth. Every instruction sent by mission controllers must be carefully planned because a round-trip conversation with the spacecraft takes nearly 2 days. There is no room for mistakes. Even a minor software adjustment requires extraordinary precision. As the spacecraft's power supply slowly decreases, NASA engineers continue making difficult decisions. Instruments that have completed their primary objectives are gradually turned off, allowing the remaining scientific equipment to operate for as long as possible. Each additional month of operation is considered a remarkable achievement. Eventually, Voyager's scientific mission will come to an end. Its transmitter will no longer have enough electricity to send signals back to Earth, and the spacecraft will fall permanently silent. But silence does not mean the journey ends. Long after its final transmission, Voyager will continue orbiting the center of the Milky Way for millions of years. Attached to its side is the famous Golden Record, carrying greetings, music, natural sounds, and images chosen to represent life on Earth. The chances of another civilization finding it are incredibly small. Yet that was never the point. The Golden Record is a symbol of curiosity, a message placed into the universe simply because humanity believed exploration was worthwhile. Perhaps that is Voyager's greatest legacy. It transformed 2 distant planets into familiar worlds. It became the first ambassador from Earth to enter interstellar space. And it reminded us that even with limited technology, determination and imagination can carry us farther than anyone believed possible. Today, Voyager continues its silent voyage through the darkness between the stars. Each kilometer takes it farther from home. Each passing year makes its survival even more extraordinary. Somewhere beyond the fading influence of our Sun, humanity's most distant explorer keeps moving forward, carrying with it a small piece of our civilization and a timeless question that has inspired explorers throughout history. What lies beyond the next horizon? As long as Voyager continues its journey, that question remains alive, and so does humanity's desire to understand the universe.